Good evening, dear students. So today the fourth session of vector algebra. We are going to start with product of two vectors. Okay. Before I start the class, please confirm that you are able to view the screen properly and able to hear my voice very clearly. Just give a confirmation. Okay. Thank you very much. So now, what is the product of two vectors? Before going to discuss on the product of vectors, let us understand that what about the product we are so far aware of. Think about, you have two integers and you are going to make a product of these two integers, okay, or in generically I can say that you take two numbers and the product of two numbers you get as a number. You take two matrices, you make the product of two matrices, you get again a matrix. But let us think about a function. When we multiply two functions, we can multiply them in two different ways. Okay. The first one is pointwise multiplication and the second one is the composition of two functions. So let me give you an illustration here. Suppose we have two functions fx and gx. So now when you want to make a product of these two functions, so there are two ways we can achieve it. The first one, what is here we have mentioned in the adjoining note, is that it is a pointwise. Okay, so that means what? We get the product as fx into gx. Let's assume x be a real number. So for every real number, what we get, that fx as a real number. For every real number x, we get fx as a real number and gx is also a real number. So we are assuming both fx and gx are a real valued function. That means what? That if you recall the function notification, that f R to R and g, that is also from R to R. Now when you make fx into gx, that is actually a pointwise multiplication. And what the result we are going to get? We are going to get the result as a number, real number. Okay, and that is actually you can see that you get the value of x equal to 2, you get a value of fx, that is a real number. You get the value of x gx g2, that is also a real number. So when you multiply f2 into g2 for x equal to 2, you get another real number. So that is pointwise. Now the second one is actually the composition of function. Let me use a different color. Composition of function. What is composition of function? Composition of function, dear students, is that it is something like that: g of fx. If you remember, g naught fx composition. So that is equal to what? That is equal to g of fx. That means if you have a real number x, first you find what is fx. Okay, that will also be a expression in x, and based on that you find g of that fx and you get another function of x. So that is composition of two functions. If you notice, dear students, that in pointwise multiplication the result is a real number, whereas in a composition of two functions, whatever we get, that is a function. So we see that the way we multiply two functions, based on the methodology of the multiplication, sometimes we get a real number, sometimes we get a function. This is exactly happening in case of a product of two vectors. Suppose we have two vectors a and b. Okay, one vector a and another vector b. So there are two ways we can multiply them. the first two multiplication gives us a result which is a scalar, and the second category of multiplication gives us the result as a vector. So that means what? So the scalar product is generally denoted by a dot product. So it is A dot B. Okay, you know, dear students, both A and B are vectors, but A dot B, that will give us a scalar quantity. That means it will give us a value which is not having any direction. Okay, and obviously it doesn't follow the vector law of addition. And another one is that is known as a cross product. So that is what? That is, as it is cross, so it is symbolically denoted by A cross B, and the result of A cross B is a vector. Okay, so that means what? It has both magnitude, it has direction, and also it obeys the law of vector addition. So what we see, dear students, when we have two vectors A and B, based on the methodology of the product, sometime we get a scalar quantity, okay, sometime we get a vector quantity. And you know, both of these two types of products, so you may have a question that why these two types of products are there. You know, vector is used extensively in mathematics like geometry and engineering like mechanics, okay, branch of engineering mechanics. So based on that, these two products has been designed, and both these products, that is a scalar product A dot B, that is known as a scalar product or dot product. You know, here it is written scalar product or dot product. So whenever you see the scalar product or dot product, it is actually denoted by this. And whenever, let me use a different color, whenever we use vector product or cross product, that is actually denoted by this one, A cross B. And both these type of products has various applications in geometry, mechanics and engineering. So we are going to discuss about these two products in details, their properties, and if our time permits, we will go with some examples as well. As usual, at any point of time, if you have any smallest query, never hesitate to ask me about it. Okay. So dear students, so first I am going to start with the scalar product, that is a dot product. So let me bring the relevant note here, and after that I am going to explain it. So how we are going to define the scalar or dot product? So let me first bring it the note in a proper position, and then let me explain. So let us consider two vectors, dear students. Vector A, this is the vector A as you see here, okay, and another vector B. So two vectors we have considered, A and B, and their scalar product is denoted by A dot B. And how they are defined? They are defined as A dot B equal to mod A, that means magnitude of the vector A, into mod B, that is the magnitude of the vector B, and cos theta, where theta is the angle between the vectors A and B. Okay, where theta is the angle between the vectors A and B, and there is a condition that theta should be in between 0 to pi, including both 0 and pi. So I repeat once more, dear students, that the scalar product or dot product of two vectors A and B, and those vectors, there is a precondition to non-zero vectors. If the vectors are 0, if any one of them is 0, then you will see that the dot product result will be 0. So if the scalar product of two non-zero vectors A and B denoted by A dot B, that A dot B, and how they are defined by? They are defined by mod A into mod B into cos theta. If you notice, dear students, few minutes back I told that A dot B is a scalar quantity. and it is evident from the result of A dot B from the definition. How? Mod A, it is a scalar quantity, it is a magnitude. Mod B, that is also a scalar quantity, is a magnitude, and cos theta, that is a real number, we know, right? It is a real number between -1 and +1. Any real number between -1 and +1 is actually the value of cos theta belongs to the closed interval -1 to +1. So the product of the three real numbers, that is mod A, mod B and cos theta. So it is a real number, it is a scalar quantity. Now if any one of them is a null vector or zero vector, that means if A is a zero vector or null vector or B is a zero vector, then theta is not defined. We no need to define theta. Theta is not defined, and in that case what we can say that A dot B is equal to a 0. A dot B equal to 0. You will notice that A dot B, there is a vector notation on A, that is why there is a arrow on A. Vector notation on B, that is why there is a arrow on top of B, but the result is a pure real number 0, no vector. So that means again it signifies that the scalar product of two vectors is a scalar quantity. Okay, that is why it is called scalar product or dot product. I hope things are clear by this time. If any doubt is there, as I always say, never hesitate to let me know about it. Now let us going to make some observations, and these observations are extremely important to realize the significance of dot product, and also to answer questions, and based on to answer questions you need to take assistance of these observations. Okay, I am going to explain each of these observations, okay, in details. So the first one, dear students, is that as you see, let me first place it very well. Yeah. The first point, that A dot B is a real number, that we are already aware of, we have just discussed. Now the point 2 is that let A and B be two non-zero vectors and A dot B equal to 0. Let us do it. Before completing the statement in point number 2, let us understand what will happen if A dot B equal to 0. That means what we see is that, dear students, that A vector dot B vector is equal to 0. So we know what is A dot B. We know A dot B equal to mod A into mod B into cos theta, that is equal to 0. Now according to the statement in the point number 2, that point number second observation, let A and B be two non-zero vectors. That means what? That means both A and B are non-zero vectors. That means mod A and mod B cannot be equal to 0. Mod A, that is why it is a non-zero vector, that its magnitude cannot be equal to 0. Mod A cannot be equal to 0, and mod B, that also cannot be equal to 0. But mod A into mod B into cos theta equal to 0. How it is possible? It is only possible if cos theta equal to 0, and I hope all of you are able to get it. So that means cos theta equal to 0. Why? Because mod A is not equal to 0, mod B is not equal to 0. Now when cos theta can be equal to 0, where theta is in between 0 to pi, including both 0 and pi, that means 0 less than equal to theta less than equal to pi, only value of theta for which cos theta can be equal to 0, where theta is in between 0 and pi, is that theta equal to pi by 2. What does it mean? That means the angle between the vectors A and B is 90 degree. That means what, dear students? If we have a vector A something like this, okay, suppose this is the vector A, just a minute, this is the vector A, and let me draw the other vector in the blue color. Suppose this is the vector B, okay, and the angle between A and B is 90 degree. Then without much understanding we can say that the dot product between these two vectors A and B is equal to 0. And the other way, if you see that A dot B equal to 0, you can conclude that A and B are perpendicular to each other. And conversely, if you find that A dot A is perpendicular to B, then you can conclude that A dot B equal to 0. That's why this statement has been mentioned here. A dot B equal to 0 is implied and implied by, that is called implied and implied by, both sides arrow, okay, implied and implied by A is perpendicular to vector A is perpendicular to vector B. That means what? If A dot B equal to 0, that means A vector is perpendicular to B vector, and if A vector is perpendicular to the B vector, then you can say that vector A dot vector B is equal to 0. Now the third point, if theta equal to 0, then A dot B equal to mod A into mod B. That is also quite obvious. Let me explain here. So in general, what is A dot B? In general, we know that A dot B is equal to mod A into mod B into cos theta. Now if theta equal to 0, then what is the value of cos 0? We know the value of cos 0 is equal to 1. So that will become mod A into mod B, if theta equal to 0, correct? I hope you got a very clear idea. Now based on that, there is a statement A dot A equal to mod A square. Okay, how come? Because we know that, let me also elaborate this one. So what is A dot A? A vector, dot product with the same vector. So that will be what? It will be mod A into mod A into the angle between the vectors A and A. A vector makes an angle 0 with itself. So obviously it will be cos 0. Okay, cos 0 degree, let me write it down, or 0 radian, whatever. So that is equal to 1. Okay, so what we can say, that is equal to mod A square. Correct? I hope you got it very clearly. In the similar manner, if you see, so third point we are able to address it. Fourth observation, if you see, if theta equal to pi, then what we get, dear students, is that A dot B equal to minus of mod A into mod B. How come? So let me explain it. If you see here, dear students, that theta equal to pi, that means the angle between the vectors A and B is pi, 180 degree. So that is equal to mod A into mod B into the angle is pi, so we are writing it's cos pi. We know the value of cos pi, that is cos 180 degree, is minus 1. So you can write that is equal to minus A vector into mod of A vector into B vector. I repeat once more, when theta equal to pi, A dot B is equal to minus of mod A into mod B. Correct? Now its special case is that when both the vectors are, one vector is A and another vector is minus A. So that means what? A dot minus A. Now think about. So that will be equal to what? This will be equal to mod A into mod of minus A, and the angle between the vector A and minus A, this will be 180 degree. How you know? Let me show you. Suppose this is a vector. So let me write down, this is a vector A. Okay. So this is a vector A, and here, as you see, let's assume O be the initial point and capital A be the terminal point. So what will be the vector minus A? It will be exactly opposite direction. Let me do it in the draw it in the green color. So how it will be? It will be something like this. Okay, and let's assume that this vector minus a having the initial point O and terminal point as a dash. Now if you see, dear students, that the angle between the vector a and minus a, that is equal to pi, because that is 180 degree. So that's why we can write here that a dot minus a is equal to mod a into mod of minus a into cos phi. Now we know that mod of minus a is nothing but mod a, correct? So what we get? We get here is that mod of a whole square, and we know the value of cos phi is equal to minus 1. So we get minus of mod a whole square, that is the value of a dot minus a. I hope the point 4 of the fourth observation is well understood. Now let us look into the three mutually perpendicular unit vectors I cap, j cap and k cap. If you recall from the previous session, dear students, we know what is I cap, j cap and k cap. They are the unit vectors along the direction of the x-axis, y-axis and z-axis respectively. So if I give you a quick recap here, dear students, so what we can I can draw the three mutually perpendicular, in fact I can draw the coordinate axis. Okay, now if we assume that O as the origin, and this is x-axis, this is y-axis and this is z-axis. Now what is I cap? It is a unit vector in the direction of the x-axis. So maybe like this we can define this is equal to I cap, and this we can define as j cap. So the magnitude of this vector j cap or I cap is actually 1 because it is a unit vector, and this is k cap in the direction of the z-axis. So now I dot I will be what? Mod I into the angle between I cap and I cap, that is 0, right? So mod I cap into mod I cap is equal to 1. So that is why I cap dot I cap equal to 1, j cap dot j cap equal to 1, k cap dot k cap equal to 1. Okay, we have understood this thing, that point number 3, that a dot a is equal to mod a square. So similarly I cap dot I cap should be equal to mod of I cap square. We know mod of I cap is equal to 1, so it is 1 square, that means 1. And the second one, dear students, is that I cap dot j cap. I cap dot j cap means what? Is that the angle between I cap and j cap is 90 degree. So we can easily conclude, as the angle between the vectors I cap and j cap is 90 degree, so definitely their dot product has to be 0. That is coming from this one, this second observation, right? So I cap dot j cap is equal to 0. In the same logic we can say j cap dot k cap is equal to 0 and k cap dot I cap equal to 0. I hope you got this point as well. Okay. So whenever we will see the vectors described in the component form, so we need to simplify it, so we will use this logic that I cap dot I cap equal to 1, j cap dot j cap equal to 1, k cap dot k cap equal to 1, and I cap dot j cap is equal to 0, z cap dot k cap equal to 0, and k cap dot I cap equal to 0. So this is the fifth observation. Now let's come to the sixth observation, dear students, and here it is the angle between two non-zero vectors a and b. Suppose we need to find the angle between two non-zero vectors a and b. The vectors is known to us, that means we know the magnitude and the direction. So how we can find that? To find that one, there is a very simple methodology what we can make use of the dot product. So let me elaborate here. What is A dot B? If you recall the fundamental definition of dot product, that is equal to mod A dot mod B into cos theta, the angle between the vectors A and B. So from here we can simply write that cos theta is equal to A dot B divided by mod A into mod B. Now as both the vectors are non-zero A and B, so we know the vectors A and B, so we can easily find the cosine of the angle between them, and by means of inverse trigonometric function, dear students, we can find the value of theta as cos inverse of A dot B divided by mod A into mod B. So that is what is actually mentioned here, but I just elaborately explain you that why so. So sixth observation, I hope you got it very clearly. Now all these observations, I repeat dear students once more, the significance of observations is that it will help you to solve numerical problems, okay, very effectively. You need to make use of these 7 observations. Now the last observations, that is A dot B equal to B dot A. Let us see how it is A dot B and B dot A. So what is A dot B, dear students? If you recall, A dot B is equal to mod A into mod B into the angle between the vectors A and B. So let us assume the angle between the vectors A and B is theta. So then what we will get? A dot B equal to mod A into mod B into cos theta. Now what is B dot A? B dot A will be, dear students, that will be equal to mod B into mod A into the angle between the vectors B and A. If the angles between the vectors A and B is equal to theta, the angles between the vector B and A will be minus theta. So that will be cos of minus theta. Let me explain it, dear students. Suppose we have 2 vectors. I am representing the vectors in the green color. Okay. Suppose this is the vector A, okay, and there is a vector B. Suppose this is a vector B, and the angle between the vectors A and B is theta. So we measure in the anti-clockwise direction. So this is the angle between the vectors A and B. Now what will be the angle between the vector B and A? That should be measured in this direction, and it is turning out to be minus theta. Correct. So now we know the value of cos minus theta equal to cos theta. So that will be equal to what? That will be equal to mod B into mod A into cos theta, because I repeat, cos minus theta is equal to cos theta, and that is nothing but whatever you see in the red color here mentioned, that mod A into mod B into cos theta. So that is equal to A dot B. So what we see, that A dot B equal to B dot A, or other way we can say that dot product is commutative in nature. I hope all these 7 points are well understood, dear students, and let me proceed to the next step. Okay. So let me bring that notes from my saved place. Okay. So this we have done. Now let me go to this one. Now we are going to see the 2 important properties of scalar product. So let me write down both the properties here. The first property is the distributive property of scalar product over addition. So here 2 operators are coming. One is the scalar product, and the second one is the addition. And the second one, second property I am going to represent is that this one. Okay. The first property says that if we have just a minute, I think there is a superimpose happening. Got it. So the first property says that suppose we have two operators. The first one is that scalar product, and let me write in the red color. Okay, first one is the scalar product, and second one is the addition. So then what we can say is that A dot B plus C, all three are vectors, is equal to A dot B plus A dot C. Here that the scalar product is getting distributed over addition. Okay, so there is distributed means what? In the left hand side you see there is only one dot product, but in the right hand side you see there are two dot products. That's why it is getting distributed. Distributed over what? Distributed over the operator plus, that is the addition. I hope you got a very clear idea. So let me remove all this, right? So this you need to remember. A dot B plus C is equal to A dot B plus A dot C. Now if we have two vectors A and B, and lambda be any scalar, this part is not required. So what we can write is that lambda A dot B is equal to lambda into A dot B is equal to A dot lambda B. So this is the second property. Okay, lambda is a scalar, that is a real number. Okay, now let's say the two vectors A and B are represented in the component form. Okay, if you recall the component form we discussed in one of our previous session. That means what? The vector A is nothing but that A1 I cap plus A2 j cap plus A3 k cap. So this is the way we represent the vector A. And how we are representing the vector B? In the similar manner, B is equal to B1 I cap plus B2 j cap plus B3 k cap, where I cap, j cap, k cap are the unit vectors along x, y and z axis respectively, and obviously A1, A2, A3, B1, B2, B3 all are real numbers. Now how we are going to make that A dot B? So obviously A dot B will be equal to A1 I cap plus A2 j cap plus A3 k cap dot B1 I cap plus B2 j cap plus B3 k cap. Now we are going to make use of the properties, both the properties, property 1 and property 2. So first we are going to use the distributive property of dot product over vector addition. So it will be one what? A1 I cap dot B1 I cap plus B2 I cap plus B2 j cap plus B3 k cap plus A2 j cap into B1 I cap plus B2 j cap plus B3 k cap plus A3 I cap in dot, actually into means I wanted to mean dot B1 I cap plus B2 j cap plus B3 k cap. After that again we are going to do the same thing, okay, the distributive property. So we get A1 B1 I cap dot I cap plus A1 B2 I cap dot j cap, A1 B3 I cap dot k cap, and the other things are self-explanatory. Okay. Now we know that I cap dot I cap equal to 1, j cap dot j cap equal to 1, k cap dot k cap equal to 1. So A1 B1, A2 B2, A3 B3 means this value is equal to 1, this value is equal to 1, and this value is equal to 1. Rest all the values, that means I cap dot j cap, that is equal to 0. We know they are mutually perpendicular vectors, I cap and j cap. I cap dot k cap, that is also equal to 0. So that means this is, if I use a different color, this is 0, this is 0, this is 0, j cap dot I cap 0, then j cap dot k cap 0, k cap dot I cap 0, k cap dot j cap 0. So that means finally what we get, dear students, is that we find the value of A dot B as A1 B1 plus A2 B2 plus A3 B3. So this is an important result when both the vectors A and B are represented in the component form. I hope you got a very clear idea. Now let's go to the next part, and that we are going to discuss about the projection of a vector on a line. Very important. In fact, this has immense application in physics, in mechanics. I hope you have gone through it as well, but here also I am going to explain and hope you will enjoy it. Okay, what is that? What is meant by projection? Okay, and for example, if you think about the physics, mechanics, the force, when multiple force is acting on a particle, then you need to discuss the projection of one force along the direction of the other. Okay, these are very practical phenomena in physics problems. Now here we are going to discuss the projection of a vector on a line. So for that, what we need to have one vector and one line, and it is a directed line. So we are considering, dear students, so there is a vector AB and there is a directed line, so it is a vector AB. There is a vector AB and there is a directed line L, and the vector AB and the directed line L makes an angle theta in the anti-clockwise direction. For a symbolic representation in the diagram, if you see, this is the directed line L, that is why there is a direction here. Okay, and the vector A is actually AB, where A is the initial point here and B is the terminal point, and L is a directed line. So that means the direction is in this one, and this is the vector AB as you see it here, and the angle between the vector and the directed line is theta, and that theta is measured in the anti-clockwise direction. And what we are going to see, dear students, then the projection of the vector AB on L is a vector P. Okay. So what is that? The projection of the vector AB on L is a vector P, and is a vector P. So as it is a vector P, it has both magnitude and direction. So its magnitude is mod AB cos theta. Okay, so that is the magnitude. And what is the direction? The direction of the vector P is same as the direction of the directed line L if cos theta is positive, and it will be negative if cos theta, it will be not negative, sorry, the direction of the vector P will be opposite to the direction of the directed line L if the angle between the directed line and the vector is theta, then cos theta if cos theta is negative. So let me write it here, dear students. So what is the vector P? P is the vector, okay, which is the projection of the vector AB on the directed line L. Now that vector has a magnitude and has a direction. What is the magnitude? If we see, its magnitude is mod AB cos theta. Now what is theta? We just discussed theta is the angle between the vector AB and the directed line L measured in the anti-clockwise direction, that is the magnitude. And what will be the direction? Its direction will be the same as that of L, same to that of L if cos theta is positive. Okay, so that is one thing. Or it could be opposite to that of L, opposite to that of L if cos theta is negative. I hope you got a clear idea, but the idea may not be clear by the time, but you got the result, but we will show it actually here. Now recall that where cos theta is positive, cos theta is, if you recall, the all sin tan cos rule. So let me write it here. So if you recall, both we are going to establish here, both by means of the diagram, what you see in the left hand side in the blue color, and the right hand side whatever I am going to show in the green color. So we know this is the first quadrant where theta is in between 0 to 90 degree. So 0 degree less than theta less than 90 degree, and here cos is positive because all trigonometric functions are positive in the first quadrant. In the second quadrant, what we see is that it is between 90 degree to 180 degree. So 90 degree less than theta less than 180 degree, and we know in second quadrant cos is actually negative, correct, no? In the third quadrant, if we come to third quadrant, that means 180 degree less than theta less than 270 degree. Okay, so here we know that cos is negative. Then let's come to the fourth quadrant. In fourth quadrant, what? The theta is actually 270 degree less than theta less than 360 degree, and here cos is positive. So what we see, dear students, here that when theta is in between 0 to 90 degree, how geometrically it looks like. You see it here that this is the vector AB and this is theta. So we get AB cos theta. So if you look into the right angle triangle ACB, where this angle is 90 degree, then what will get cos theta? Cos theta is equal to P by A, correct, na? If you recall, cos theta is equal to in fact we can write is that mod P by mod A, correct, no? Correct. So what we see it here is that in this one what we get here is that that both vector P and vector A, we can find the value of the cos theta equal to mod P by mod A. So what we get is that this is the way the projection happen, and you see here the direction of the vector P and direction of the vector L both are in the same direction. Okay, direction of the L and direction of the P are in the same. Now let's come to the second quadrant. That means when theta is in between 90 degree to 180 degree. So here you see this is the theta is an obtuse angle. Okay, 90 degree to 180. So how it looks like? This is the direction of the vector L. Okay, so if I write it here, so this is the direction of the vector L. Okay, and this is the vector AB, and you see this is theta. So 90 degree less than theta less than 180 degree. And what we get it here, dear students, is that if you look at it, that how we can find the projection. So projection, the way we can find it is that is the projection AC. Now if you see, this is the vector P actually. If you see it here, this is the vector P, and the direction, if you see, is exactly opposite of the direction of L, correct? And how it is possible? It is possible because there are two ways you can see. Geometrically you see the direction of P is exactly opposite to the direction of L, and also algebraically you can see, because when theta is obtuse, that means from 90 degree to 180 degree, the value of cos is negative because it is in the second quadrant. Now let's come to the value of theta when it is 180 degree to 270 degree. Okay, between 180 degree to 270 degree, what we see is that, if you see, this is a case where the angle between the directed line and the vector is 180 degree measured in the anti-clockwise direction. Here also you see the vector P is actually in this direction and the vector L, so if I say the vector P is in this direction and the vector L is in this direction. Okay. So then what we get here, dear students? So then we see the the value of theta is in the range of 180 degree to 270 degree, which is in the third quadrant, and in third quadrant we see the value of cos is negative. So both from geometrically, as you observe here, and algebraically, as I have mentioned it here, we see that direction of the vector P and that of the directed line L are in the opposite direction when theta is in between 180 degree to 270 degree, as the value of cos of theta is negative in that case. Now let's come into the fourth case, that is when theta is in between 270 degree to 360 degree. So how it will looks like, dear students? So 270 degree to 360 degree, so this is something like this. Okay. And here what we get, dear students, sorry, excuse me, dear students. So now here what we see, dear students, that the vector P is in the same direction of the vector A. You see, if you look into from the projection point of view, if you see same way, the way I explained for the first case, if you look into this right angle triangle ACB, right angle at the C, and you see that that we get the direction of the vector P and direction of the directed line L are in the same direction. Okay, or other way I can say the direction of the vector P is in the same as that of the directed line L. And how? Because when theta is in between 270 degree to 360 degree, at that region or at that range of values of theta, we get the cos is positive, because in the fourth quadrant cos is positive. So what we get is that cos is positive, hence the direction of the vector P and that of the directed line L is same. Okay. So I hope you got a very clear idea about the projection of a vector on a line, and let's now proceed to the next point, dear students, and what is called this vector P. That vector P is known as a projection vector. Okay, so let me bring it here. This vector P is known as a projection vector. Okay, so and its magnitude is obviously mod P, is simply called the projection of the vector AB on the directed line L. Okay, so what is called, dear students? That projection of the vector AB on the directed line L. For example, in each of the following figures, projection vector of AB is along the line L is the vector what? Is the vector AC, if you look into the diagram here. In all these cases, you see the projection vector AB along L is the vector AC, which we defined as a vector P. Okay. Now, if you see the direction of the vector AC and the directed line L, to understand how they are actually correlate as theta varies in the four quadrants. I hope you got a very clear idea about the projection vector, its magnitude, its direction. Now let's proceed to the next point. There is some observations on these projection vectors and that we are going to discuss now. So the first one. So let me first place this note here, and after that I am going to explain. So if P, the first one, if P is the unit vector along a line L, then the projection of a vector A on the line L is A dot P cap. That is quite obvious from the whatever we discussed in the previously. If P cap is the unit vector along a line L, then the projection of a vector A on the line L is A dot P cap. How come? Let me give you a visual representation. Suppose this is a line L, this is the line L we are getting. Sorry, this is the line L. This is a directed line segment L. Okay. Now, what is the vector P? Okay, P is a vector, is a unit vector along this line L. That means what? So, suppose this is the vector P and its magnitude is 1, that is why it is a unit vector. Now, we have another vector A, and that vector A I am describing something like this. That vector A, suppose this is a vector A. Okay, so this is a vector A. Now, what we see here is that that this is a vector A on that and whatever we are going to find, we are going to find the projection of the vector A on the line L. So, what we are going to find, it is A dot P cap. So, that is the projection. Okay. So, what will be the value of this thing? It is mod A into mod P cap into the cosine of this angle between the A and P, measured in the anti-clockwise direction. Okay. So, what we are going to discuss here, what we are discussing at present here is that how to compute the projection of a vector A. That is our point. The point of discussion is that how to find the projection of a vector A. How to find the projection of a vector A along what? Along a line L, where we get a unit vector P cap. Okay. So, this is when you are going to find the projection of a vector, so it has to be projection along a line. Now, on that line we get a unit vector P cap. Okay. So, what we get? A dot P cap. A dot P cap, that is the projection of a vector A on the line L, that is A dot P cap. I hope you got it. Now, if we get a vector A and we need to find the projection of the vector A on another vector B, that is in the similar manner A dot B cap, or we can say what is B cap? B cap is nothing but the vector B divided by the magnitude of the vector B. That means B cap is nothing but B vector by mod of B vector. So, that is A dot B vector by B vector, that means A dot B, A dot B. So, from here we get here that A dot B by mod B. Now, so you got the second observation. Third observation is that if theta equal to 0, then the projection vector AB will be AB itself. Obviously, if theta equal to 0, the projection vector of AB is AB itself, because it is the same line, right. So, here projection in fact does not make much sense. And if theta equal to pi, then the projection vector of AB will be BA. That means it will be in the exactly opposite direction of the vector AB. Okay, done. Now, the fourth observation is that if theta equal to pi by 2 or theta equal to 3 pi by 2, then the projection vector of AB will be a 0 vector. Okay. So, obviously, because in projection what comes is that cos is coming because of the dot product, the value of cos pi by 2 is 0, value of cos 3 pi by 2, that is also equal to 0. So, we got the observation based related to the projection of vector. Now, let us proceed to the next point. Okay. And that is the remark, and After that we will conclude the class for today. In the next class we will make some practice on dot product. So dear students, a very important remark here. So if you recall about the direction cosine, it is related to that. Let alpha, beta, gamma are the direction angle of a vector A, and the vector A is represented in the component form as A vector is equal to A1 I cap plus A2 j cap plus A3 k cap. Then its direction cosines may be given as cos alpha equal to A dot I cap by mod A into mod I cap. We know A dot I cap is nothing but A1 because it is A1 mod A because we know that A is A1I plus A2j plus A3k. Now if we make a dot with I, so how it is going to happen? So let me compute this one. What it will be that A vector dot I cap. So that will be equal to A is, we know that A1 I cap plus A2 j cap plus A3 k cap dot I, the unit vector along the x-axis. So that will be equal to what? If we apply the distributive property, distribution of the dot product over vector addition, so it will be A1. If we write, it will be A1 I cap dot I cap plus A2 j cap dot I cap plus A3 k cap dot I cap. So j cap dot I cap, that is equal to 0, we know, because both j cap and I cap are mutually perpendicular vectors. We know when two vectors are mutually perpendicular, their dot product is equal to 0. So this is equal to 0. In the same logic, k cap dot I cap is equal to 0. So we left with A1 I cap dot I cap. I cap dot I cap equal to 1. We have earlier looked into it in observations of dot product. So you get only A1. So that's why it is A1. And we know mod of A is equal to mod of A as it, but mod of I cap is equal to 1. I cap is a unit vector, its magnitude will be 1. So we get cos alpha equal to A1 by mod A. Similarly, cos beta will be equal to A2 by mod A, and cos gamma will be A3 by mod A. So dear students, if we know a vector representing a component form like the one you see, that A vector is represented as A1 I cap plus A2 j cap plus A3 k cap. This is the component representation of the vector A, and if alpha, beta, gamma are the direction angle of that vector, then we can derive the direction cosine as cos alpha equal to A1 by mod A, cos beta equal to A2 by mod A, cos gamma equal to A3 by mod A. Or other way I can say cos alpha equal to that I cap component of the vector A, that is A1, divided by mod of this vector. Similarly, cos beta equal to j cap component of the vector A, that is A2, divided by mod of this vector, and cos gamma equal to k component of the vector A, that is A3 by mod of A. Also, we need to note that mod A into cos alpha, mod A into cos beta, and mod A into cos gamma, that means mod A into cos alpha, mod A into cos beta, mod A into cos gamma, are respectively the projection of A along OX, OY and OZ respectively. Obviously, what is A1? A1 is nothing but mod A cos alpha, right? From here, if you see, if I just explain with 1, then you will understand the other part. Cos alpha equal to 1. Cos alpha equal to what? A1 by mod of A1. So that means what? That means, okay, let me write in the next line. So this implies that A1 is equal to mod a1 into cos alpha. So that value we can write it here, sorry, that value if I write in a different one, this value we can write it here. So then what we get, a1 is nothing but the projection of a along OX. Similarly, so a1 is nothing but mod a cos alpha. Similarly, a2 will become mod a cos beta and a3 becomes mod a cos gamma. So what we get, dear students, that mod a cos alpha, mod a cos beta and mod a cos gamma are respectively the projections of a along OX, Y, OZ, that is the scalar components of a1, a2 and a3 of the vector A are precisely the projection of A along x-axis, y-axis and z-axis respectively. Further, if A is a unit vector, then it may be expressed in terms of the direction cosines as A equal to cos alpha I cap plus cos beta j cap plus cos gamma k cap. Now here we mentioned that A is a unit vector. Unit vector means what? Its mod magnitude of this vector will be 0. That means if A is a unit vector, that means mod A should be equal to 1, and that is quite evident. What is mod A? Mod A, if we from here we see what is the value of mod A? Mod A equal to square root of cos square alpha plus cos square beta plus cos square gamma. We know if cos alpha, cos beta, cos gamma are the direction cosines, the sum of their square is equal to 1, that is equal to square root of 1, that is equal to 1. I hope you got a very clear idea. Now in the next class, dear students, so what we will do, we will make some practice. As you see that this kind of questions we will make some practice. With this note, let me conclude the class here, dear students. If you have any question, you can ask me and I will be answering that one.